introduce myself. My name is Roger Jones. I've been with Sonus for a little over a year now. I am the CTO of EMEA, Europe, Middle East and Africa, and I'm here as a person to work with all of you to bring you up to speed with the Sonus solutions, help you with customer engagements, of course. So that's my role in life. I have a technical background. Just before I joined Sonus, I worked at a little company called Avaya for about 13 years. Some of you may have bumped into me in that time, some of you may not. Anyway, let's proceed on with the presentation. And first of all, I'm hoping that you can see the screen on the web conference here. We have, of course, our usual legal disclaimer, which we will quickly whiz past. And let's look at the SBC market opportunity that we have in front of us. So these figures are from Infinetics Research, and we have two segments to the SBC marketplace, which we'll be talking about today. We have the service provider marketplace, which is on the bottom here in blue, and of course we have the enterprise marketplace, which is on the top with green. And you can see the projected sales or the figures for SBC sales in terms of millions of dollars projecting out to 2017. As you can see, that it's a significant market coming in at around $1 billion in 2017 with a 15% compound annual growth rate. For those of you who don't actually work in the service provider environment and are predominantly in the enterprise environment, let me just give you two or three indicators of why the service provider marketplace is larger than the enterprise marketplace, and also where they use those SBCs. So, as you're all familiar, I'm sure, the service providers have been providing us with the ISDN connectivity down to enterprise customers for 25, 30 or so years. And slowly, in some countries, it's not in every country. Typically, competitive service providers are starting to deliver voice over IP using the SIP signaling protocol into customers. It's a much lower cost way of bringing bringing voice trunks into enterprise customers if you don't have an existing ISDN estate to look after. And it's a significantly more flexible solution than traditional ISDN. So to do that, those service providers need to be able to have, obviously, IP connectivity from their service provider points of presence, from their exchanges down to the enterprise customers. And at that point, as they slowly increase their SIP trunking level, they're going to be supporting thousands and thousands of SIP trunks down to their enterprise customers. And to secure the edge of their service provider network working, they need a session border controller at the edge of their network to provide that level of interoperability and also for security. Just as a quick message, you cannot get webinar to call my phone. It fails with a messaging capability function is not enabled. Well, Michael, I apologise for that. I'm not sure why that's happening. It certainly works for me when I'm using it. There are a number of telephone numbers included in the invite, which you can ring if that will help you out. And so, of course, so the service providers, the main focus for a lot of people is these what we call access SBCs that sit at the edge of their network and protect the service provider from the enterprises, and also provide an interoperability and a demarcation point for them. Increasingly, the service providers are using SIP to connect between each other. So France Telecom to British Telecom, for example, that's traditionally been ISDN connectivity. And of course, as those operators start to go towards an IP-based network, they're starting to use SIP for their interconnect as well. So again, that's a very large part of the session border controller marketplace, is the SIP interconnect marketplace. The third and still quite new part for service providers is really in the mobile area, where most of you, I'm sure, will be familiar with the concept of 4G or LTE, and so that the long-term evolution, high bandwidth mobile networks. In some parts of the world, and probably in the US to start with, we are starting to see some early rollouts of something called voice over LTE, which in all fairness is not a great deal of difference between using a SIP soft phone over an IP network, and the fact that your LTE handset effectively has a SIP soft phone on board, which makes voice calls over the IP network instead of over the traditional GSM, CDMA or 3G network. And so voice over LTE requires the service provider to have a session border controller at the edge of their network to be a demarcation point between those LTE handsets and their SIP core. And so, as I'm sure you can appreciate, if voice over LTE becomes a significant market, and I did say if, there will be a significant requirement for service provider SBCs. So I just wanted to give you folks a little bit of an indication of why that marketplace was large. And of course, enterprise SBCs, you know, the typical headline for this will be an enterprise wishing to have a SIP trunk from a SIP service provider, and of course wishing to have an interoperability and security and demarcation point at the edge of their network, which is where an SBC comes in. But we also see SBCs being used to integrate between disparate systems. So if you want to integrate an Avaya communication manager to Microsoft Lync 2013 and you want to use encryption, then you're going to need an SBC because they don't talk encryptions. So Lucas, you cannot hear anything. I'm assuming that other people can hear me. If someone could just type something saying yes or no. If we're having problems with audio, I'd appreciate it. Thank you, Alison. That's good. Okay, there's a few messages coming in. I'm hoping that someone can hear me apart from Alison. Anyway, I shall continue on. We can hear you. Thank you very much. Excellent. Now, Dan can't see the slides. Dan, you're not having a good day. And I'm wondering if that is the same Frank Lang that I used to work with at Avaya. Anyway, let's move onwards. So, let's look at the enterprise session border controller marketplace, and it's how it grows over to calendar year 17, and how that growth is split across organizations of different sizes. And as you can see from this this diagram here, the light grey in the middle, the 151 to 800 users, is a very significant part of the enterprise market. This is the global view of the enterprise marketplace, and you can see that that's a very large chunk. And so it's very important that as you approach the enterprise marketplace, you have products which are appropriate for this level of users, this level of call concurrency. And the good news for Sonus, as we'll see in a few slides' time, is that we now have a very wide portfolio of products which cover the whole range of enterprise customer sizes, from the very small with our SBC 1000 up to the very, very large with our SBC 5210 product, which we'll talk about a little bit later on. As I say, we will distribute these slides out to you. Now let's look at, as it's almost part of my job description and has been forever, is that you need to put a Gartner Magic Quadrant into the mix. And here is last year's Gartner Magic Quadrant. As I'm sure you'll all appreciate, it's becoming towards the end of October 2013, so we probably are due a new Gartner Magic Quadrant. I do know that we've input information into Gartner. I haven't seen any output to date. So this is last year's one. You can see that we are in the leaders quadrant for session border controllers with with a little company called Acme Packet, who of course were acquired by Oracle earlier this year. So we're looking forward very much to understanding how the Magic Quadrant looks in 2013, but we're very happy to be in the Leaders Quadrant for 2012. So speaking of others, let's look at the whole marketplace here for session border controllers in 2011 and 2012. And, you know, we'll all be the first to admit that Acme Packet were very much the early leaders into this marketplace over the last 5 or so years. And of course, when you are in that significant leaders position, it's a very difficult thing to hold on to. And so we took a good lump of market share from Acme between 2011 and 2012. We are hoping when Infinetics do their next analysis at the end of 2013, we will have some even better news, and we will have expanded our market share. So these figures here are for the global SBC market, that's service provider and enterprise. The folks at Infinetics have also done a breakdown of enterprise SBCs and the market share, and you can see in 2012 that Cisco were the market leaders with 25.6%, and Acme with number 2, and we were sitting around 7.4%. Now, one of the things that some of you may know, and some of you may not know, that in the summer of last year, in 2012, Sonus bought a company called Network Equipment Technologies, NET, which some of you, I'm sure, have a relationship before that. And so when these 2012 figures were calculated for enterprise SBCs, we'd only had NET for one whole quarter and a couple of weeks on top of that quarter. So the 2012 figures didn't really significantly include the NET, the legacy NET part of our portfolio, which of course is now fully Sonus portfolio. So if we take a snapshot from Infinetics at the halfway through this year, you can see that we have made some significant advances in our market share, and we are now a very close number 3 to Acme Packet, and really not very far away from behind Cisco. So of course, if you are a Cisco partner, that's fantastic. If you are not a Cisco partner, Cisco's market share in the SBC business is pretty much irrelevant, because the Cisco Cube only works on Cisco call managers. It doesn't go across any other vendor's products at all. So if you are someone who is not concerned with the Cisco marketplace, that's the Cisco number there isn't particularly relevant to you. But we're very happy on that. Whether those figures continue to look the same at the end of 2013, we shall see. We're obviously working very hard to do that. So if you'd come and talk to Sonus just about the middle of 2012, sort of June time 2012, this is before I joined them, Sonus had 2 SBC products on the marketplace, the SBC 5200 and the SBC 9000. And as you can probably see from those numbers, they are very big. They're significantly larger than the Acme Packet products that were available at that time. And I'm sure you'll understand that these were really focused on the service provider marketplace. And so the traditional part of the original Sonus organization has come from a service provider background. But as I said earlier, we acquired Network Equipment Technologies in the summer of 2012, and if we now look at our SBC portfolio for the middle of 2013, i.e. now, well, we're just slightly past the middle, you can see that we've significantly expanded our portfolio. So first things first, the 5200 got updated to the 5210 with just a few enhancements around modularity of digital signal processors. We added the 5110, which goes from 250 sessions to 10,000 sessions, again quite a big boy, but for the larger enterprise, the large contact center, the 5210 certainly has its place in the market. And then we had added the products that were originally called the UX 1000 and the UX 2000 have now been rebranded the Sonus SBC 1000 and SBC 2000. And those are, as you can see from the session counts, the concurrent call counts are enterprise-focused session border controllers. So, what's the fantastic thing about these session border controllers? Well, apart from the fact that we have the broadest range of SBCs in the marketplace from a single vendor, we certainly go lower than Acme Packet, and we certainly go higher up than our friends at Audio Codes. And the other good news is that the 4 lower SBCs are Lync qualified. So the 1000, 2000, the 5110, the 5210 have all been Lync 2010 qualified. The 1000 and 2000 are Lync 2013 qualified. You will find all of that on the Microsoft UCOIP pages. And at the end of November this year, I did want to say this year, the 5110 and the 5210 will also be Lync 2013 qualified. They have actually already passed all of the tests, and all we have to do is actually launch the version of software that passed, which is version 4, which is due at the end of November. So we are, obviously we've not done, to make sure that Alison doesn't panic and have a heart attack, we haven't publicly announced this to the market yet because we haven't made the software generally available. But from a sales perspective, we have a fully Lync 2013 qualified portfolio. And if anybody asks why isn't the SBC 9000 Lync qualified, we've yet to find a Lync environment that needed a high-end TDM or ISDN to sit the gateway of this size and complexity. So we don't currently have any plans to put the SBC 9000 through Lync qualification. So what's some of the special stuff around the Sonus SBCs? Well, as usual, it's from a lot of this network-focused product, it's around the architecture. It's a very, very nice coincidence that NET and Sonus had architected their products in a very, very similar way. So we have these 3 axes, these 3 arrows here with the 3 key components of our SBC family. First of all, the actual the general computing engine that's doing all of the routing and the call processing through the SBC is done on a general CPU, which allows us to obviously build in a lot of flexibility in the capabilities for doing SIP message manipulation and all that good stuff. We then have in the product some dedicated network processing hardware, which allows us to do this wire speed security. It allows us to do all of our protection against denial of service attacks, and it allows us to do our wire speed signaling and media encryption as well. So when you buy any of the SBC products, you get the general CPU and you get the network processing elements. What's modular on the product is the digital signal processors. All of the products support the ability to add, or if you wish, subtract DSPs from the mix. And where do you need digital signal processors? Those are required when you're doing transcoding. So if you're transcoding from G711 to G729, or a customer wants to use HD audio inside their IP network, G722 for example, and the service provider only supports G711 on the SIP trunks, and so at that point you'd want to transcode traffic that was going out of the network or coming into the network from G711 to G722. Also processing DTMF traffic and also processing fax traffic is where you have those dedicated DSPs. Now, Sonus, because of its long heritage in the ISDN or TDM to SIP marketplace has actually developed its own DSP technology, and so we have some fantastically optimized DSPs for transcoding, and that's why we're always very happy to go into a shootout with the other SBC vendors, particularly when transcoding is involved, because we have much higher performance transcoding. I'm going to come back to a little bit to transcoding in a few slides time, folks, but that's just to give you some idea of the architecture. So let's talk about the SBC 1000 and 2000 now, and where they fit into one of your customers' environments. So you're going to have many customers who are sitting in this type of environment today. They have a traditional PBX with primary rate ISDN connectivity out to the service provider. I mean, it could be a full TDM PBX, it could be an IP PBX with gateway technology converting out to TDM trunks as usual. You may have analog phones, you might have IP phones. You know, that's pretty traditional and pretty typical, and the customer's thinking, right, there's a couple of things I'd like to do. I'm interested in maybe implementing Microsoft Lync into my environment. I'm interested in investigating an alternative service provider with SIP trunks. How can I do this? You know, what are my options here? So first things first, using our SBC 1000 or 2000, you have this effectively a drop-in installation. If you configure either of those SBCs with the correct number of E1 ports, primary rate ISDN ports, you can actually connect it in between the PBX and the PSDN. And you might think, well, that's sort of interesting, Rog. Why would I want to do that? What's the benefit of doing that? You're just putting another component in the middle of my network. Well, the key here is that if the customer is serious about a migration to Microsoft Lync, or maybe even a migration to another SIP-based PBX, it could be a ShoreTel, it could be a Mitel, it could be any of those things. What this allows us to do is it allows us to put in our SBC 1000 or 2000 here and connect that, in this example, the Lync, the SIP-based Lync unified communications platform out to the traditional PSDN. But it also allows us to continue to have our older TDM PBX or an older IP PBX still connected to those SIP trunks. And what we do is hopefully the customer is using Active Directory, and if that is the case, the Active Directory is configured to talk to the SBC, and as inbound calls arrive onto the SBC does a lookup on AD to decide whether to route the calls to a Lync endpoint, to the Lync client, or to the traditional PBX that's in the network. So giving you a real painless interconnection. Outbound calls obviously are generated by each platform and go straight out through the SBC, and inbound calls we can pre-route them using Active Directory lookups, which is in many cases something the customers are very keen to do because they only have to maintain Active Directory as their database of telephone numbers. Now, of course, what we can do, I showed this with traditional PSDN, good old TDM PSDN. It's now very easy to add a SIP trunk into the mix. So we can have both a TDM PBX, a Lync environment, TDM PSDN and SIP PSDN all running at the same time, making sure that you've obviously you've scoped the product to ensure that it's large enough to support that amount of traffic. And we can also support IP VPNs if you want to create a VPN across an IP network to another location as well. We also support the ability to register SIP endpoints onto the SBC 1000 and 2000. And why would you want to do that? Well, it's not an everyday occurrence, everybody, but if you are migrating away from an IP PBX, and you have the ability, as you do with Cisco and Avaya, I know, to flash those phones to be SIP. You can then register, those SIP phones can then register with the SBC 1000 and 2000 and be proxied in as a basic Lync endpoint. Okay, so you can reuse those endpoints, those SIP endpoints, via the SBC onto the Microsoft Lync platform. Now, please be aware, folks, that this is only going to give you basic telephony on those SIP endpoints. It's not going to give you any advanced features like presence and instant messaging or anything like that, but it will allow you to reuse those SIP endpoints if that's what the customer needs to do. And of course, we can install both BRI and analog cards into the SBC if you need to allow you to support good old fax machines and any elevator phones, any lift phones, any old analog devices that you've got knocking around in that enterprise customer's environment, and it will route that traffic out through the PSTN or if required out through the SIP trunk as well. So really it's an any-to-any connectivity. We call it a session border controller because you can run it as a pure SBC with IP to IP traffic, but we also have the capability to do ISDN to SIP, ISDN to ISDN, analog to SIP, ISDN to analog, any different combination that you want to do. And it's the real Swiss Army knife of UC applications here. So let's move on and talk a little bit about some other capabilities, just some highlight capabilities that we have on the 1000 and 2000, and that's really in a Microsoft Lync environment where we have branch offices. So some of you will be familiar with the LSP functionality from Avaya Communication Manager. You might be familiar with Cisco's SRST capability, Survivable Remote Site Telephony. Well, Microsoft Lync 2010 and Microsoft Lync 2013 also have a survivable solution, and there's some subtle differences between the two versions. So let's do the common ground first. So on the left hand side here we have the enterprise headquarters. They have an IP WAN which is stretching out to a branch office on the right hand side. Both offices have traditional, well, it doesn't have to be traditional PSTN, but let's, for this example, say that they've both got primary ISDN connectivity for their local numbers in both locations. So in Microsoft Lync 2010 and Microsoft Lync 2013, you can install the SBC 1000 or 2000, depending on the size of the office, in that branch location. And inside that SBC, we have an optional server blade, which can run, is an Intel server blade, which can run pretty much any application that you want, obviously processor and memory dependent in there. But one of those applications is a Microsoft application called the Survivable Branch Appliance application. And the way this works is that in that branch office, the Lync clients, when you boot your PC up or you switch on your Lync phone, will register to the SBA as a local registration, and the SBA will proxy those registrations through to the core Lync servers. In normal operation, your voice traffic, your enterprise voice, your instant messaging and your presence information is all flowing across the IP WAN, and the PSTN is used when you're making external calls, and you can decide which office you want to break those calls out of. All pretty straightforward stuff. Nothing particularly complicated. In the event that you lose the IP WAN, the SBA application running in the SBC in the branch will ensure that those Lync clients can still make telephone calls in and out of the branch office using the PSTN. Okay, the IP WAN fails, the Lync clients remain registered. Because the IP WAN's gone, they have lost instant messaging, and they have lost presence, and they've lost desktop sharing, like I'm using at the moment. But they will continue to have voice survivability. And that is a general feature with Microsoft Lync 2010 and Microsoft Lync 2013. So as you're specifying an SBC 1000 or 2000 in a Lync environment where you need survivability, you put in a SBA, you put in a server blade from Sonus, which is one of our part codes, and that can come with the SBA software preloaded. That server blade does support virtualization. It can support other applications. For example, we've tested call recording embedded into the SBC 1000 and 2000 with red box recorders. So you can load the red box recorders, calling voice recording application physically inside the SBC, as an example. Now, what Microsoft did in Lync 2013 is they added a further survivability option, which is the ability to have a second backup route using a 3G or 4G router. So we've implemented this into the Sonus SBC 1000 and 2000 family. So in the event that your IP WAN fails now, what happens is the voice calls are routed over the PSTN as before, but your instant messaging and presence traffic and your signaling traffic moves over to the 3G, 4G network. Okay? So there's a couple of subtle differences in the design for Lync 2013. Firstly, you don't need a server blade in every branch. You don't need a server blade in any branch. The server blade in Lync 2013 with 3G, 4G failover resides in the central SBC in the headquarters. So that's a significant lower cost solution because you only have one server blade in the environment, not one per branch office. You do need a 3G, 4G router at both ends of the connection to provide that connectivity. But the other good thing about this is that if you lose the IP WAN, voice traffic continues over the PSTN, instant messaging and presence traffic continue over the 3G, 4G network. So it gives a much better failover and quality of experience for those people in the branch office with the enhanced SBA with 3G, 4G failover. And just before some of you rush off to quickly check on the audio codes data sheets, no, they don't support this yet. Okay, so we are currently the only vendor who have this advanced or enhanced SBA functionality for Microsoft Lync 2013. So that's what they call a USP in the old days. Okay, just moving on, folks. Let's as we're doing a sort of an overview today, I wanted to talk to you about our SBC 5000 series products, where there are two models, the 5110 and the 5210. These are very high performance session border controllers, IP to IP session border controllers. These do not support ISDN or analog interfaces. But as you may appreciate, as they come from a service provider background, they have a very high level of redundancy. They have very high levels of encryption and transcoding capability built into them. The DSPs in the 5110 and 5210 are modular and field installable. So if a customer needs to expand DSPs or move DSPs from one platform to another, they're perfectly able to do that. We also support H.323. We support IPv4 and IPv6 and conversions between the two without performance degradation. We have full high availability, which I'm going to cover in the next slide. We have some fantastic SIP header manipulation, which is very important for interoperability. We have a lot of technologies around security, topology hiding, VoIP-aware firewall, traffic policing, denial of service protection, call admission control. It's all built into these products. Fantastic routing capability coming down from our very large service provider routing heritage. We have very good CDR capability from these products. It's obviously you can work on that how you like, but it is service provider class CDR capability. And we have a lot of centralized management, billing and performance management options on the SBC 5000s as well. So just to talk a little bit about high availability, some of your customers will require a highly available SBC, so we can implement the 5000 series in active standby high availability mode, whereby the active SBC is processing all the calls and all of the information on those calls. The call state is being relayed across those HA ports between the products into the standby box. So in the event of the active box failing or the connections to the active box failing, the standby box will automatically take over and preserve those calls. So it's called preserving failover. I know, and I'm going to get in there before someone asks on the chat, Rog, does it support geographical redundancy? The answer to that is yes, but you do need to do some network engineering to ensure that happens. You have to have layer 2 links between the products to allow them to share IP and MAC addresses between the active box and the standby. So it is technically possible, but it does require some network engineering to make those geographically redundant. So that was a very quick one. What I want to do now, folks, is in the last 10 minutes is take you through a brand new product that we launched just about 2 weeks ago. It's going to go generally available in the middle of November, on November the 15th, and that is our new software or a virtual SBC. Okay. So Sonus have an SBC as a virtualization strategy. We are virtualizing the majority of our software components around network management, our routing engine called the PSX, our CDR gathering device called DSI, are all being virtualized in the early part of next year. But the other thing we're doing is we're taking the SBC 5000 code and we have ported that over to a virtual machine environment, and so you'll be able to deploy a software-based SBC onto a customer's virtual server environment. Okay, so that's what we've done. We've made some announcements. The product has the rather snappy name of the Sonus SBC Software Edition. Okay. It is based on the well-proven technology of the SBC 5000, which has been around for quite a few years now. It shares 95% of that SIP functionality of the SBC 5000. Okay, there are a couple of things that it doesn't do in this current first release of the software edition, but it does do the majority of things that the SBC 5000 does. And it's also going to start at 25 sessions. So for a customer who wants a small IP to IP session border controller, they don't need any ISDN or analog connectivity, the Sonus SWE is going to be a very flexible platform for you to provide SBC functionality for those customers. So what have we actually done? How have we got here? So we talked about our 3 axes from our SBC family, and this is the SBC 5000 here, where we have a general CPU, we have the network processors and the DSPs. Now you might think, and if you look at the majority of the other software-based SBCs on the marketplace, that we're going to lose some of that traditional hardware functionality. Well, yes we are. But we're not losing all of it, folks, because we've done some really rather cool engineering. If we have the software SBC, the SWE, it does of course have a CPU. The underlying server will have a number of cores in its CPUs, and the virtual server hypervisor has the ability to create virtual CPUs which we run across. Because we own the microcode for the network processors in our products, and we also own and have the intellectual property for the DSP microcode in our products, we have managed to port those into our software SBC. So our software SBC is capable of doing those security functions that the network processor previously performed. And we also have the capability to have soft DSPs. Now, I want to be very clear here, folks. A software DSP does not create as many concurrent transcoding calls as a hardware DSP today in today's technology. But we do have some transcoding capability in our software SBC. So we are going to be able to provide, we need to look at the design, of course, the ability to have all of those critical SBC functions in a purely software delivered environment. Okay, so it's a very important message. You're all thinking, there's a number of questions. Rog, what hypervisor are you working on? Well, the first release in November will be running on VMware, and it is very much our intention to add in other well-known hypervisors in short order in 2014 to allow this to run on different virtualization platforms. We do support something called the OVF format, which means it's very easy for us to port it into other other hypervisor platforms. It's really just a matter of testing it. The other question you're all dying to ask, well, if you're still awake, is, Rog, how many concurrent calls will the software SBC perform? Well, the answer to that question is, what server have you got, Mr. or Mrs. Customer? And we will have in the next couple of weeks a cheat sheet for you that says, right, my customer wants to support 350 concurrent calls, G711 to G711, with TLS on one side and unencrypted on the other side. What server do I need, Rog? And we'll be able to provide you with an answer. So that information is nearly finished. It will be finished before the general availability of the product. If any of you need to reach out to me or via Westcon, which is probably easier from my bandwidth perspective, if you have a burning desire, we can give you some early indications of what the server platform is likely to be. So what's one of the other interesting things here is we also support high availability in our software SBC. So you can have two instances of the virtual SBC installed on two different servers. That probably makes more sense to do this. And it will support the high availability failover that the larger boxes support. And this is again call preserving HA. Our SBC 1000 and 2000 products we talked about earlier don't support high availability in this way, not call preserving. So we've always had a problem in a smaller customer who insists on having high availability has to buy the larger product. That issue is going to go away as we have the virtual SBC, which supports high availability. And I also know that some of the technical guys in there will say, oh, can we support NIC teaming? Well, as long as the underlying server platform and in the first instance VMware is configured to support NIC teaming, which is active standby NICs on a server, yes, we will support that, and it is transparent to the SBC functionality. So the question is when is hardware right and when is software right? Well, hardware is, for a while, is still going to be the right answer if the customer needs to do a significant amount of transcoding or they're doing a significant amount of encryption on their in their environment. And when we mean significant, when you're starting to talk in the multiple hundreds or getting up to the sort of 500 above concurrent transcoded calls. It is entirely possible with the software SBC, but the server platform that you need to do it is going to be really quite expensive. And so it may well work out if your customer is doing a significant amount of transcoding that the actual hardware appliance would be a cheaper option. But if you're looking for deployment flexibility, the ability to squirt an SBC down into a customer's virtual environment, you're looking to host SBCs in your environment in a virtual server farm and apportion SBCs to individual customers, it's going to be very much easier to run up multiple instances of the software edition, as we say, starting at 25 sessions and then growing up into the thousands of sessions range depending on the underlying platform. So why is the SWE important for you guys? It dramatically expands the addressable marketplace that you can reach. Previously a lot of customers have looked at session border controllers, thought it's an expense, thought it looks like a really big piece of kit, and they maybe said, right, we're going to stick with our ISDN trunks for another year or so. Now, if we're looking particularly around in that sweet spot up to about 800 sessions and below, the SWE will go above 800 sessions, I can assure you of that. But in that sweet spot, we now have a software-only offering, which, if a customer has the virtual server environment, should come in at a significant lower cost, and it's much faster to deploy. And again, we do have a remote centralized management of the product. The management interface is the same as the SBC 5000. It's either a CLI or a full web-based interface, depending on which way you prefer to do these. So just looking at where the SWE solution example, so partners for yourselves who are looking for a scalable and flexible model for selling SIP trunking solutions. If you are in the SIP trunking marketplace and you have either been thinking about customer premise equipment for those customers, or you've been fighting and installing customer premise equipment, maybe it's time to relook at that and think maybe I can host that customer's software edition SBC in my virtual server farm, or maybe it's much easier for me to deliver that. I've been down in various parts of the EMEA region, and I've been talking to partners who are very interested in bundling the software edition SBC inside some virtual PBX and virtual communications products they've built for themselves. So there's a whole range of things that you could do with customizing and installing the software edition inside an existing product offering you have. We always hear about people with no room in their wiring closets or no room in their data centers. If they're running a virtual server environment, we can then quickly squirt an SWE in there. Looking at networking and UC application providers to embed their SBC functionality into an existing product. Do you know of a product that you sell that has an Intel blade or a server blade inside? Maybe you can embed the software edition inside. Anybody who's looking at virtualized data center technology, whole concept of network functions virtualization, which the SBC is a network function, and we have virtualized it. So NFV, which is a 3-letter abbreviation, quite keen, the press are keen on at the moment. We are now, well, in the middle of November, we'll be delivering that. And also, you know, there might be some different options around disaster recovery. So today, you know, in a disaster recovery environment, there is if you're using a hardware appliance, there is a physical investment that needs to go in and taking up rack space. This will this allows you to do all sorts of different things with virtual SBCs and placing them and moving them very quickly. A quick response to Patty. Yes, we will definitely be distributing the slides. I am also recording this call, and if it's manageable to do so, we will we'll make a copy of the recording available as well. So just coming up to near to the top of the hour, let's just put this together in a solution diagram. So this diagram here is a concept, okay? So if we start at the top, we have maybe a cloud provider. I've shown our two partners here in the cloud space, which is Microsoft and BroadSoft. And as they connect their services into the various different service providers around the region, they will want to have an SBC to protect the border of their network, and the service provider will do the same. I've just shown here in this example that we're using the software edition in that place, and the service provider is using a 5000 series as their interconnect SBC. The service provider is then using an SBC 5000 as their access SBC to provide those SIP trunks down to our enterprise customer who has 2 data centers. In data center 1, they have some highly available SBC 5000s, probably 5110s. They have Microsoft Lync. In the second data center, they've got a good old Cisco Unified Communications Manager, if that's what they're still calling it this week. And in there we have installed an HA pair of the SWE in that environment. And then we go down. In our local office on the bottom left-hand corner, we have Lync users in that part of the organization, and they're using their Lync clients. We've installed the SBC 1000 or 2000 with the survivable branch appliance capability in it. I've given them some analog trunks to play with as well, and so that gives those Lync clients some survivability in the event that they lose connectivity to their data center. We've got a good old Avaya call center. The majority of the calls from that call center are being routed up through data center 1 and out through the HA pair of the 5110. But as you know, nearly every contact center manager in the world is indeed a very paranoid individual. I'm sure that's part of their job description. And so we've installed a disaster recovery software edition SBC into their virtual server environment to provide them with either overflow or a backup to their main SIP trunks coming from their Avaya call center. And then down on the right hand side, our customer's still got an old Siemens ISDN PBX. Could be an Alcatel, could be an Avaya, could be nearly anything really, but let's call it Siemens. And that's connected via primary rate interfaces into the SBC 2000, which is converting those ISDN connections into SIP and routing them up through data center 2 back to the service provider. Why have we done this? Well, we've done this to reduce the number of ISDN lines in all of these locations and consolidate those ISDN lines into data centers 1 and 2 with SIP trunks. And we have a way of bringing in those older PBXs that still have some time left in them, and we can convert them over to SIP using the SBC 1000 and 2000. So this is just an example of how we fit into a multi-vendor environment with our various different products. So just to sort of highlight this, if we now look at the Sonus SBC portfolio for the middle of November 2013, we now have six SBCs in our family. I agree that for 99.999% of you, the SBC 9000 is not a product you're ever going to get involved in. But we do have a very wide portfolio of session border controllers. Now, there's just a couple of things I want to bring up about the software edition. The software edition, when it launches in November, will not be Lync 2013 qualified. It is based on code that is Lync 2010 qualified. It won't appear on the Microsoft website. It is very much our intention to have the SWE Lync 2013 qualified early in 2014. We don't have an exact date for that yet, but that is our intention. And the other thing here is it does say on the SWE customer defined sessions, which some of you might be thinking sounds like marketing. It's nearly, because the SWE is going to go on a customer provided server. It's very difficult for us to give you a headline bullet point on the number of sessions that product will support. We do need to go through a quick overview of the server that the customer wishes to use, the amount of RAM it has, the amount of virtual CPU resources it has to work on. From that point, we can work out how many sessions it's going to support, and you will have those tools by GA to allow you to do that as well. So as I'm, as usual, running out of time, my final slide, I'd just like to say that Sonus has been in this SIP business for a very long time. Started back in 1997, very much in the service provider environment, and is now in 2013 as both a service provider and an enterprise-focused organisation. We're very, very focused on multi-vendor interoperability, and we have a very good ability to scale with high reliability. So at that point, folks, we haven't had many questions on the chat room. If you wish to put a chat question in, or you wish to use good old voice technology, feel free to do so. I'm not going anywhere. I'm happy to stay here and answer any questions. You will have my information on the front of these slides. I can actually put up the final slide, which also has my email address if you wish to send me an email question, and you can even ring me up on the telephone as well if you wish to do that. Thank you very much for your time, and I hope to meet you all soon and talk to you again. Thanks, bye.